Now I'm going to talk about something which is not exactly related to direction of vectors, but it's quite important that I wish to elaborate on it now. Okay, so over here I have another vector represented by this green arrow here. I purposely draw this green arrow to be double the length of the blue arrow. So this vector here is supposed to have twice the magnitude of the S, this vector S over here. Okay, I'll label it as S subscript 2. The subscript 2 means that S means by it's a displacement vector, so it's the same type of vector as previously. The subscript 2 just means that it's another displacement, so it's not the same as the previous displacement, it's another displacement. Okay, so S2 here is supposed to have double or twice the length of S, and because they are both pointing in the same direction, the direction is also 45 degrees above the positive x-axis. Okay, so now we know that these two vectors S and S2 have the same direction, and the magnitude has a relationship of times 2. S times 2, the magnitude of S times 2 will be the magnitude of S subscript 2. Okay, so if we know there's this kind of relationship between two vectors, we can actually express the relationship in an equation like this. Okay, so this is the original vector S, and if we multiply it by 2, what will happen is it will become S subscript 2. So why multiply by 2? Because 2 is a scalar. Okay, let me do something over here. Okay, so because 2 is a scalar, if you multiply a vector by 2, what will happen is it will cause a change in the magnitude. Okay, 2 is a scalar, right? So 2, the number 2 here has no direction element in it. Okay, so it can only cause a change of magnitude, but it can't cause a change in direction. Okay, but there is an exception actually. If your scalar, if this value here happens to be a negative value like -2, let's say, okay, so if it's a negative value, then what that scalar will do is it will flip the direction of the vector. So let's say if this is -2, then -2 will be pointing somewhere this side with the exact same length as S2, but in the opposite direction, because the negative will flip the direction. Okay, so just something to be careful about. If you put in a scalar value, you can only change the magnitude. For the direction, the maximum that you can do is flip the direction by adding a negative sign. Okay, so 2s here will be equals to the vector S subscript 2. Okay, so let's say now we have another vector, and this vector is S subscript 3. And let me clear everything out because now I'm going to do a similar thing. So S subscript 3 here, if I rewrite it, S subscript 3 will be having the same magnitude. I purposely draw S2 and S3 to have the same length of arrow, just that the arrow here is flipped downwards, so the angle is the same, but now it's below positive x-axis, not above anymore, it's below. Okay, so now the direction is different, and they are not that kind of flip, that kind of different. They are like totally different. They are not parallel. If you are flipping a vector from one side to another side, the two vectors are actually still on the same line, so you can still call it anti-parallel or parallel. Okay, but now it's not even on the same line. It's not even parallel or anti-parallel anymore. It's a totally different direction, but now the magnitude is still times 2. So in this case, if you want to express the relationship between S subscript 3 and S, you can no longer say that it's equals to 2 anymore. Even though the length is really twice of S, the length of S subscript 3 is actually twice of S, but because the direction is not parallel, not in the same direction, you cannot just put it equals each other. Okay, you have to take care, you have to consider the direction also. If the direction is not the same, it cannot be equal to each other. Okay, so because they are not parallel, then therefore they are not equal to each other. Okay, so just to remind you that if you are talking about equations that involve vectors, you have to be sensitive about the direction, not just the magnitude.